Hi, O5O. Today we're going to talk about some story problems that have to do with graphing, slope, rate of change, and I thought it would be helpful if we went over the even ones together. And so we're going to be using your books, page 678 to 679, and we're going to start with number 50. So number 50 has a truck and it's going up a highway, and it says find the slope or the grade of the road. And so you can see that the truck is going up a road that has 2,400 meters, and as he's driving up he's rising 148.8 meters. And so to find the slope of the road, and it also says or grade, so the real clue here is grade, the word grade. They want us to make a percentage of this. And so this would be the rise, the 148.8 meters, and then the run is going to be the 2,400 meters. So we would just write that as a fraction, just like you would write the slope. 2,400 meters, and then you're going to just find the percentage. So you could put x over 100. And if you remember when we were doing proportions as percents, you multiply 148.8 times the 100, you cross multiply, and then you divide by the 2,400. So I hope I gave you enough time. And so the answer then is in percentage form, and so you get 6.2%. Again, that was number 50 in case you weren't on the page yet. Okay, so let's look at the next one. So the next one is actually 52. So 52 says, constructing chairs. Carpenters use slope when designing and building stairs. Public buildings normally include steps with 6-inch risers and 11-inch treads. Find the grade of such a stairway. And you can see from the picture that it's rising 7 inches. And then they call this part the tread. And the tread then is 11 inches. So for every step, this is 7 inches, this is 11 inches. So we need to look for our question, and it says find the grade. And so the grade again is going to be the slope as a percentage. So if you think about it's rising 7, it's running 11, that's going to be our slope. And then we're just going to change that into a percent. And again, the reason we're doing that is it's asking for the grade. So when we're looking for grade, we changed the percent, we changed the slope into a percent. So go ahead and do the math on that. Okay, so hopefully you remembered that you're going to multiply 7 by 100 and then divide by 11. And when you do that, you get 63.63 repeating, and it just repeats 63, 63, 63 over and over. So we could round this to 63.7%, or we could say 63 and just use that fraction 7 over 11%. So either of those would be a correct percentage. Okay, so now let's look at the next one. The next one's fun for us Coloradans because it talks about a very popular peak in Colorado, Long's Peak. And it says, the slope of Long's Peak from a base elevation of 9,600 feet, Long's Peak in Colorado rises to a summit elevation of 14,256 feet over a horizontal distance of about 15,840 feet. Okay, so first of all, when we're solving this, and again, the question is find the grade of Long's Peak. So remember, if we're looking for grade, we're going to be looking for a percentage of the slope. So somewhere way back in Kansas, probably, it may even be farther east than that, we're going to have 0 altitude. And then when you get to the middle of Kansas, I know for sure the altitude starts rising, so by the time you get to the Colorado-Kansas border, it's probably at least 1,000 feet. And then by the time you get to Denver, it's 5,280 feet, right? Because it's a mile high. So if you are one who decides to hike a 14er, you're not starting at 0 somewhere in Kansas. You're starting at the base. And the base of Long's Peak is 9,600 feet. And so you climb that, and it's very steep, all the way to 14,296 feet. Your horizontal distance is the 15,840. So by the time you start at the base and you get to the top of Long's Peak, horizontally, you would have gone 15,840 feet. So we're looking for our rise. We don't really know right now what's the difference between the base and the peak. So we're going to go ahead and just find out by subtracting those two numbers. 6 take away 0, 9 take away 0, 12 take away 6 is 6, 13 take away 9 is 4. So our amount that we're actually climbing from here to here is 4,696 feet. So that's going to be our rise. Then the run is going to be that horizontal distance. And so now we're looking for the percentage of that. And so go ahead and find the percent. And you should get about 29.4%. I actually got 29.6, so I'm going to see if I subtracted wrong, or I may have just written a number down wrong. Nope, that part was right. So our percentage is 29.4. If you got 29.6, then your calculator did what I did as well. And so that would be also the rate of change too. Okay. All right, so let's continue and let's look at that graph on page 679 that shows the injuries on farms. So number 56 says, in 1998, there were 37,775 injuries on farms to people under the age of 20. Since then, this number has steadily decreased. Using the following graph, find the rate of change rounded to the nearest 10 in the number of farm injuries to people under age 20 with respect to time. So you can see on the graph, in 1998, there were 37,775 injuries on the farms. In 2009, there were only 15,876. So this is going to be a graph that has a line falling. And it's a good thing that it's a negative line because that means that the injuries have gone down. And so the first thing you're going to need to do is you're going to need to find slope with those two points. So let's make this point 1 and we'll make this point 2. Remember, this is the x, this is the y, this is the x, this is the y. And our equation is y2 minus y1 over x2 minus x1. So go ahead and do the math, and I'll do it also as you are doing it. So did you get a negative 21,899 over 11 years? So this would be our slope, but they want a rate of change. So that means per year, what would the change be? So we would divide the 21,899 by 11. You're going to get about 1990, and then it says 0.8. So we could say 1991. You could round that up per year over 1. So 1,991 injuries per year. And because this is negative, it's negative, so it's decreasing that much per year. There are 1,991 fewer injuries each year on the farm from 2009 to, or from 1998 to 2009. All right, and we've got a couple more, so let's look at 58. So 58 talks about the population of Charlotte, North Carolina. The change in the population of Charlotte, North Carolina is illustrated in the following graph. Find the rate of change to the nearest 100 in the population with respect to time. And so you can see that in 2010, the population of Charlotte was 731,424. And the population of Charlotte in 2000 was 540,994. And so again, we're going to start by just finding out, well, what would the slope be? And so if this is point, that should probably be 0.2 though. 0.1, and if this is 0.2, I'm going to see if this actually makes sense to do it this way. I guess we'll get a negative. So let's go ahead and make 2000.1 because that's where you would start. And then 0.2, let's make 2010 because that comes after it. It makes more sense to do it that way. And so we're going to be subtracting 2010 for our x's. So I'll start with this. So 0.2 would be 731,424 minus 540,994 over 2010 minus 2000. Okay, so go ahead and do the math on that. I got 185,430, and then of course 10, take away 0 is just going to be 10, so over 10 years. So our rise would be 185,430, our run is 10, and then if we want to know the rate of change per year, we would divide by 10, and we would get 1,855.43 over 1. So 18,543 people per year, an increase every year from 2010, or from 2000 to 2010. So every year it's increasing by 18,543. Okay, so now let's look at number 60, which talks about bottled water. So even though this uses numbers from probably when most of you were either not born or just babies, so this part isn't your fault, but you do know that people use way too many plastic bottles of water. And so it's probably been increasing since even before that time. Bottled water consumption per person per year in the United States has increased from 16.7 gallons in 2000 to 29.2 gallons in 2011. Oh, this is 2011. I'm sure some of you were born by 2011. Find the rate of change, rounded to the nearest tenth, in the number of gallons of bottled water consumed annually per person per year. So again, we're going to do this one a lot like we did the other one. This is going to be 0.1, and this will be 0.2. Remember, y2 minus y1 over x2 minus x1 is our equation. So go ahead and do the math. Comma there, comma there. So this is going to be our x's, and this is going to be our y's this time, which really doesn't make sense, does it? Let's move that around. Let's make this the y's, even though that's not normally how we write this, and we're going to make the x's the years, because we're going to want a rate of change per year. And so we're going to have 2011, and then the 29.2, and then we'll have 2000, and we'll have the 16.7. Okay? Okay, so So 29.2 minus 16.7. Eleven take away 0 is just 11. So we would take the 12.5 to divide it by the years, so that we could figure out what the increase of bottle use was each year. So 12.5 divided by 11 is going to be 1.1. So that's an increase of about 1.1 gallon per year, and that's per person. So each person is increasing that. This would be a really, really interesting one to do for the year 2019, since 2019 just ended. You could Google it and find out. how much gallons of water in plastic we were using in the year 2019. And then you could use this for your base right here. You wouldn't even have to look that up. You could just use the 16.7 for the year 2000. And I will give you extra credit points for that. So, 10 points for sure, and I might even make these 10 test points if you do this correctly. Okay, so let me know where you got your information. And again, we're looking for the increase of bottled water consumption. So we want to know how much bottled water was consumed in the year 2019. And then you can use their number of 16.7 gallons in 2000 to figure out how much, what the increase is now. Okay, great. Well, that is the last story problem we have. You will be doing the odd ones, and so hopefully the work that we did today will help you to figure out how do I do those odd ones in 9.3. Okay, great. See you later.